Hello everyone. Today let's solve the k-periodic Garland, right? So you can read the entire question. I'll just summarize the question or simplify the question so that we understand in a simple way or easy way, right? So I'll just come here. So what we are doing here is, the question says we are given the multiple test cases. For each test case, we are provided with the binary string. So we are given the multiple test cases. For each test case, we are provided with the binary string. So for each test case, we have been provided the binary string. We need to minimize the number of ones in the string by flipping at most k consecutive elements at the time. So we need to minimize the number of ones. Minimize the number of ones to in the string, minimize the number of ones in the string by flipping at most k consecutive elements at a time. At most k consecutive elements at a time. That's what we have to do. Our main goal is to minimize the number of ones after the flips, but the flips can only start from 1. Main thing is the flips can start from 1. This one we have to keep in mind. Flips must or should start from 1, and our main goal is to minimize the number of ones after the flips. We have to minimize the number of ones after the flips, but flip has to start from 1. This is main thing. So these 3 things. This is the main question that that they have mentioned here. So this one. So what will be the approach? So yeah, we are, what will be the approach? As usual, we'll be starting with the input handling. The first step will be input handling. So I'll just write, this will be the input handling. For each test case, what we will do, we will find the first and last occurrence of 1 in the binary string. This will be the second step. For each test case, we will find the first and last occurrence of 1 in the binary string. First and last occurrence. This is main thing. First occurrence and last occurrence. 1, right? First occurrence of 1 and the last occurrence of 1 we will find in the binary string. That is the second step. Third step, what we are doing, we will just slice the string between the first and last one. We are just slicing the first occurrence of 1 and the last occurrence of 1. Nothing but I'll just give FO and last occurrence. Nothing but the last occurrence, right? This is the third step. Next, fourth step, we are calculating the number of ones in the binary string. After slicing the string between first and the last one, we are calculating the number of ones. Nothing but number of ones we can take. This will be the fourth step. First step, input handling. Then first occurrence and the last occurrence of 1. Then we are slicing the first occurrence and last occurrence of 1. Fourth step will be, we are calculating the number of ones. So what will be the fifth step? We will make use of the dynamic programming to track the maximum gain from flipping at most k consecutive elements. We will be making use of the DP or the dynamic programming to track the minimum gain from flipping at most k consecutive elements. From flipping at most k consecutive elements, we'll be making use of the DP for this one mainly. So this is the fifth step and the important step, mainly this one, the core logic. So the final step will be, the goal is to reduce the ones in the string by using this flips, right? We have to reduce the ones in the string by using the flips that we have made in the fifth step, right? So that's what, and we will be displaying that one in the output finally. So that's what we will be doing. I'll just give output and the sixth step, or you can just call the reducing the ones in the string by using this flip. Reduce you can give, or the output. We have to display that one in the output as well, right? So this is the approach. So let's start writing the code. We will understand it better while we write the code. So I'll just come here. As usual, we'll start by reading the input from stdin and setting the input encoding to UTF-8. So I'll just give process dot standard input dot resume first step. Next one is process dot standard input dot set encoding. We are setting this one to UTF-8. So this is one thing. Next step, what we are doing, we are initializing the empty string to get or to accumulate the input data, and also we will set the starting line of the input that has to be processed. Nothing but we will in simple terms, I'll just give input string and I'll initialize this one to empty string. Also, I'll just take the current line, variable name current line, and I'll just initialize this one to 0. Next, on receiving the input from the standard input, we are accumulating the input string as well. That's what we have to do. I'll just give for this process standard input on same template for the input handling. So I'll just give data input standard input. I'll just give stdin. In this case, input string, we are appending this one to the input stdin, right? So I'll just give, so this has to be capital S. Here also I missed, I think. I'll just make this one capital S. This is fine. The next step, once all the input has been received, what we will do, we will split input into lines and call the main function to process the input. So I'll just copy the same thing and make the necessary changes. What are all the things that is required? So here, no need of data. This will be end. I'll just remove this one. I'll just remove the same. Sorry, this as well. This has to be input trim. So we are trimming the white spaces. I'll just make use of the trim. We have to read all the input lines, so I'll just make use of the flit. Also, we will, this is enough, I think. We just need to split the lines, right? So next, what we will do, we'll call the main function. Means the core logic, we have to call the main function, right? We have not yet written the main function. We'll be writing that one in the future. So I'll just leave the space. So after writing the main function, we'll call the main function over here. Next, we will write the function to read the line of space separated integers. So we have to read individual inputs in the every line, right? So for that one, I'll be making the line. Usually we were taking in the previous problem, if you have observed, we were taking a read line, right? In my case, I'll just take li in this case. So what I'll do, I'll just give return read line. Then we can split this one. I'll just leave the space, and also we can just map of number type. We are giving number, right? We can consider the big int as well. Number works in most of the cases, unless the input is very large or we are dealing with the large numbers, right? So I'll just consider number here. So next, what we will do, I'll just write the main function. We will be writing the core logic or the main logic within the main function. I'll just consider function main. So first step, what we will do, we will read the number of test cases. We have to read the number of test cases. For that one, I'll just make use of the parseInt. Let me make use of the parseInt to read. Let me go with the read line. Next, we will initialize the empty array to store the output for the each test case. We are storing the output within the array, right? For that one, we are for that purpose, we are initializing the empty array. I'll just give output or the result. I'll just take out in this case. So next step, we will loop through each test cases. So I'll just give for let I just consider this one underscore equals 0. You can consider anything. I'll just consider underscore. Underscore. We are incrementing. We can just consider I as well. I have just considered underscore. So next step, we are reading the values of n, nothing but length of the string at k. We are just, in simple words, we are reading the values of n and k. N is nothing but the length of the string and k is nothing but the number of flips that are allowed. We'll just make use of the destructuring operator. I'll just give k. Here, li. This is fine. Next step, we have to read the binary string as well, input. So I'll just take the variable name a and I'll give the read line. So this one, I'll just give read line of this thing. Next, we will find the first occurrence of 1 in the string. We have to find the first occurrence of 1 and the last occurrence of 1 as well in the string. For that, I'll just give let L equals, let's make use of index of. Right, we'll get the index where the first occurrence of 1 is found by making use of index of. So I'll just make use of index of here directly within the strings 1, right? So for the last occurrence also, we'll exactly do the same thing. I'll just take the variable name r, and I'll just give, instead of index of, we will give last index of. So we will get the last occurrence of 1 as well within the string. So I'll just give last index of, within this one, we'll be giving 1. Right? This is fine. Next, we have found the first occurrence of 1 and the last occurrence of 1 in the string. Next step is, if 1 is not found or if there is only 1 in the binary string, then we will push 0 as we cannot reduce any ones, right? So this will be the condition. So this is simple to write. So I'll just be making use of if condition here. So I'll just come here, if, so L equals -1 or L equals R, then what we will do, we will push 0, right? Out, I have considered out, I think. Yeah, out and array. Out. What we are pushing to the array, we are pushing 0. So if 1 is not found or there is only 1, we will push 0 as we cannot reduce any ones, right? So for that purpose, I'll just directly push 0 to the output array. So let me give continue here. So after this, what we will do, next we will, while explaining the approach, I had said after this one, we will be slicing the string between the first and the last one. So this one, as we have initialized a earlier, we'll directly go with a equals a dot slice with the first occurrence and the last occurrence, right? L, this will be r plus 1. So this is fine. Next, we will update n to the new length of the sliced string. Nothing but n equals, I'll just give a dot length. And also we'll count the number of ones in the slice string. After slicing, we have to count the number of ones in the slice string. I had explained while explaining the approach. I'll just give ones. In my case, I'll just make use of the regular expression over here. A dot, so match of /1 /g. So this has to work. Let's see. Or not found, then we will be displaying the empty array. Length, I'll just consider length of this. Next, we'll initialize the answer by assuming no flips. Nothing but, now minimum is ones, right? Minimum is ones -1 we have to get. So for that one, we will initialize answer. I'll just give answer. Instead of explaining, if I write this one, it will be easier to understand. We are initializing answer with ones hyphen 1 directly. Then after doing this, we'll be making use of the DP array, right? So we'll be initializing the DP array of size n filled with 0. So let DP equals, what we'll do, size n I said, I'll just take size n and we will fill this one with 0. Nothing but initializing the DP array of n of size n, we'll fill this one with 0. Next is, we will loop through each character in the slice string. After slicing the string, we have to get the some certain characters, right? We are storing in the string. So we are looping through each character in the slice string. For looping purpose, I'll just make use of the for loop. This will be for let I equals 0, I less than n, I plus plus. So this will be let x equals a of I if it is equal to 1 within the strings, right? If it is equal to 1, we are displaying 1, or if it is not equal to 1, we'll be displaying -1. I'm just making use of the ternary operator, right? So finally, after this, we'll be updating the iterated value of the DP with maximum between current iterated value of the DP and x. This is simple when I write it, actually. Instead of explaining iterated value of the DP, we have to find the max, right? For that purpose, I'll be making use of mat.max. It will be simple when I make use of the mat.max instead of the custom function, right? So I'll just give iterated value of the DP along with the x. We'll be taking the maximum value out of these things. Next, after doing this, we have to flip the k elements from the current position, right? If we can flip k elements from the current position, we will update the iterated value of the DP by checking the optimal subsolution k steps back. So for this one, I'll just make use of if condition. If I minus k, k here, I have the capital K, right? Yeah, this is fine. I minus k. If it is greater than or equal to 0, then we'll update the iterated value of the DP, right? How can I write this one? DP of I equals, again, I'll just make use of math.max, DP of I, also DP of I minus k. We will concatenate x as well. This is one thing. The next step, we will update the answer with the minimum value after considering the flips. As like we have to update the answer with the minimum value after considering the flip. So for this purpose, I'll just give answer equals. In this case, I'll be making use of min, right? We need the minimum value. So I'll just give answer and 1 minus iterated value of the DP. So this is fine. Next, the final step, these things, we will push the result for the current test case. So what we will do, well, we have to push the output. We are pushing the result for the current test case, right? This will be push of ANS I have taken. So yeah, this will be this. Final step is we are outputting the result for each test case and we are printing the result within the console. So what we are doing here, for outputting the result for each test case, I'll just make use of the for loop. For let O of out, anything you can take, I'll just take O of out, individual this thing. Cases, let me give, we have to print, so I'll just make use of the console console.log of individual test case. Console log of it has to be not 0, sorry. I hope this works. Somewhere I had missed the braces, I think. I don't know where. Just give me a second. So I had missed this last brace, I think. Bracket, sorry. So this is it. Now let me hit the run. Let me take the input first. I'll just copy this input. We have to get 125400, right? So I'll just come here. So program did not output anything. So I have to give main here. So I'll just give main here. I forget this most of the times. So let me hit the run. % reference error. Read line is not defined. Here line number 21, right? So let me come here. Just give me a second. So what mistake I have done here is I have forgotten the function readLine here. So we have to write the function to read a line from the input, right? That I have forgotten. So I'll just give function readLine. So within this one, we have to read the individual input, right? Within the lines. For that one, I'll just give return input string current line. What we are doing here, we will return the current line and also will increment the line counter for the future inputs, right? For the next inputs. So this one I had forgotten. So now this has to work actually. Let's see. So yeah, this is giving us 125400, right? So what has to be the output? 125400. So this is working correctly. Just give me a second. Let me paste the same thing over here. I'll come here. Let me click on the submit code. Also here, E, right? This is K periodic Garland. So let me paste the code here and hit the submit. So let's wait. Let's wait for some time. So let's wait for some time. So yeah, here you can see this got accepted, right? So this code works absolutely fine. I had made a mistake here. So here I didn't write the readline function. Also I had missed one brace, I think, bracket, this one at the end. So these two things, mainly this one, function readline. So this one I had missed. So now this works absolutely correct. This got accepted right here. I can see. So yeah, this is it. Thanks for watching, guys.